Welcome to my channel. So in this video I'm going to cover the solution to this question, and also at the same time I'm going to follow the general steps we should follow in a coding interview. So before we start the real content for today, I would really appreciate that if you can help subscribe to this channel. So let's get started. Decode ways. So message containing letters from A to Z can be encoded into numbers using the following mapping. So A mapped to 1, Z mapped to 26. So to decode an encoded message, so all the digits must be grouped then mapped back into letters using the reverse of the mapping above. For example, AAA06 can be mapped into AAJF or KJF. So note that the grouping of 1106 is not valid. That's because 06 cannot be mapped into F. So essentially it is saying 6 is different from 06. We don't think that the leading 0 can be valid. So given a string S containing only the digits, return the number of the ways to decode it. So the answer is guaranteed to fit in a 32-bit integer. So for example, we have 12. There are two ways to decode it. One is to map it into AB, treating this 12 as 1, 2, or we just treat it as 12 and decode it to be L. And similarly, we have example 2, 3, 4, something like this. So the constraint says the length of the array is anywhere, the length of the string is anywhere between 1 to 100, and the string contains only the digits and may contain leading zeros. Alright, so it seems like we treat leading zeros as invalid. So in this case, some edge case I can think of is potentially if there is anything with leading 0, we're just going to return 0 for it. But probably we should be able to cover this case in our general algorithm. So let's see how to solve this problem. So first thing I can think of is we could do DFS on top of it. That's fine, but it's going to be quite time wasting. So instead what we could do is we could actually use like a dynamic programming to solve this kind of problem. I would say why we use dynamic programming, that's because the output is only about the number of the ways instead of the real decoded strings. So for dynamic programming, we can just keep record of the number of the ways to decode for a certain substring, something like that. So for dynamic programming, first of all, I'll need to define the DP array. So I will say DPI is the number of the decode ways to decode the substring from 0 to I-1. So, and the formula for this dynamic programming, what we could do is we could leverage so DPI is computed from DPI -1 and the DPI -2, but we cannot really simply just make use of this this formula because there are some conditions. For example, there might be some zeros embedded in the string. So when can we use when should we consider this DPI -1? So when we consider this DPI -1, we should definitely try to avoid the current position to be 0. So I would say if ISI -1, the corresponding character is not 0, then we can consider this DPI -1. So this is a condition for us to consider this. And what about DPI -2? So DPI -2, we definitely try to avoid. We will try to avoid the how to say that. So it will be like the substring, which is I -2 to I -1. So this is a substring. So if we just pass it into the string into an integer, you should make sure that if this one is between 10 to 26, So if this one is between 10 to 26, we can definitely make use of this DPI minus 2. That's because this one is legal. So having said that, I think we are pretty much in good shape understanding how we are going to do it. So let's do some coding work on this DP approach. Alright, so before we do the coding, the runtime, worth to mention it is all of n. So n is the length of the string, and space-wise is also all of n. So let's see. And also I think a better way I think I can think about is just solely based on the way we compute the DPI. It's just based on the previous two things. So what we could do is we, instead of having like a space complexity as all of n, we can make it like constant, because that is because we just need to store two numbers, and yeah, we just need to store two numbers and make use of the two numbers DPI minus 1 and DPI minus 2 to compute DPI, so on and so forth. Like just keep like a temporary two pointers to compute a subset of the story. In that case, we can save the space. And we can get like a constant space for the complexity. But for the simplicity of the coding, I would just use like a normal DP solution to solve this one. So let's do some coding work. So first of all, we will have so if I would say if probably we should check the leading zeros. Well, yep. If s is, it says that the length is not going to be empty. Okay, so if s is dot length is equal to 1, so if the length is equal to 1, if there is only a single character, then we are just going to say return if last stop equals, if it is equal to 0, then we are just going to return 0, otherwise we are going to return 1 for it. So that's the edge case. So that's because the DPI is based on two things, DPI minus 1, DPI minus 2. That's why I checked this special edge case, which is the length of the string as equal to 1. Otherwise, what we are going to do is we are going to have like a DP array to have int dbs plus 1. I'll say just s plus 1. I have, for the simplicity of it, we will have like a dp0 to be stored as 1, because like say for example there's like an empty string, then there's I would treat it as like one way to decode it. So this is just for the further computation later on. So so let's see, the next thing what we are going to do is we are going to have like the dp1. So the dp1, if it is not 0, then we are just going to, so the dp1 s.car at 0 is equal to, is it equal to 0? If yes, then we are going to return 0. Otherwise we are it is going to be set as 0, otherwise it is going to be set as 1. Actually, we can save the edge case checking here. Yeah, so actually I think we can save the edge case checking here. So let's just delete it. And the next thing what we are going to do is we are going to start from I is equal to 2, I is smaller than so it is smaller than dp, sorry, as the length, it's just smaller than as the length, and plus I. And finally what we are going to do is we are going to return dp as dot length. Yes, we are just going to return this one. Alright, so it should be like equal, exponentially equal here. Okay. So currently we are just we will try to compute DPI. So how to compute it, as like I said, we are going to see. So if s.car at I minus 1, if it is equal to if it's not equal to 0, then we can definitely have the DPI to be temporarily set as DPI minus 1. And then the next thing is we need to make sure whether we can leverage DPI minus 2 here. So you're going to say substring, okay, say string substring is equal to s dot substring from I minus 2 to currently, which is I minus 1. So we are going to use the, so I kind of forgot if it is, okay, so I think it's just okay, it's excluding the ending things. Alright, so if, and I need to parse it, integer dot parse int. I need to have this as an integer, as like I'll just have like a temp. So if the temp is anywhere between 10 to 20 to 26, then we are going to have dpi plus equal to dpi minus 2. Yep, so that's pretty much it. Let's depend on this platform to help us to do some debugging work. Alright, 12 seems to be good. Let's see some other test cases. Ran all the test cases. So this one is good. Everything seems to be good. Let's do a summation for this one. Alright, so it seems like everything works well currently. So like I said, we could actually make this piece of code to be we can actually make the space complexity to be better, because we don't need to have this array. Instead, we can just have two temporary two local variables to just store, to interleavingly store the dp I-1 and dp I-2 until we finally get the dp s.lens. So that's pretty much it about this coding question. If you have any question regarding the solution or whatever, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.